Databricks provides native access to many high-performing AI models, including Google's Gemini 3, OpenAI's GPT 5.1, and Anthropic's Claude Opus 4.5. When you're designing an AI application or agent, the model that powers it is one of the most consequential choices you'll end up making. Databricks makes it very easy to swap between different models, but without clear criteria for comparing and evaluating them, we're still flying blind. This is what MLflow's GenAI evaluation API is for. And you can use this right within Databricks. We developed a complaint triage agent for our simulated Casper's Kitchen's ghost kitchen business. It can call on various tools to evaluate customer complaints in the context of actual order data. This agent is not intended to be interacted with directly via a chat interface or something like that. Instead, it's part of a broader data pipeline and provides some classification and recommendations to reduce the decision burden for employees downstream. We need to ensure that the agent is useful in our specific context, and the underlying model plays a huge role in whether this is the case. Generic benchmarks don't help us very much. In this video, I will show how we used MLflow's trace-aware and human-aligned judges to compare models in our agent. You can find a link to this notebook and a blog with more details in the video description. Before we get into the model evaluation, let's take a quick look at the agent definition itself. I've already run a few of the cells that install dependencies and do a few other setup things, so let's jump right to the agent definition. I'll run this as we talk through it. So there are a couple of key components to the agent itself. First of all, we use Pydantic for setting up the output schema. We want to make sure to have a structured output that includes the order ID, the category of the complaint, which can be delivery delay, missing items, food quality, service issues, billing, or other, the agent's decision or recommendation, which can be to suggest a credit or to escalate for human review, the amount of that credit, the confidence in the recommendation, and the prioritization of the escalation, along with a string rationale, which is part of what we will be evaluating later in this overview. We use DSPy to define the agent itself. In particular, we'll be using the DSPy React module to handle tool calling and generating that final response. We instruct the agent to look at a complaint, use a set of tools that we have registered in Unity Catalog to understand whether the order is late, to see what the contents of the order were, to look at the average location timings for the location where the order was made, so it can determine if it's late relative to the expected timing. We also provide a decision framework in the prompt. For example, when the data don't support the claim in the complaint, so if somebody says, my burger was missing, but they didn't actually order a burger according to the order data, set a $0 credit with low confidence, which might prompt some review to understand what happened and why the customer thought that they were going to be getting a burger. We define DSPy input and output fields, which explain exactly what each output is supposed to be. So for example, the rationale is supposed to be a string, and we say that this should be a data-focused justification citing the specific evidence. And then we will ultimately map those outputs to the Pydantic schema that we defined, perform a little bit of validation, and return the structured outputs, which you can see here. Lastly, we define a lightweight wrapper around this agent that enables us to choose the model endpoint in particular, which will be important as we are comparing different models. So when we set up a new agent, we're able to define which model it should use, which will let us compare multiple different models. So let's give this a quick test. First, we're going to get a sample order ID from our data. So this will make sure that there is an actual order with actual delivery timings and order contents that we can use to try out this agent. We will enable MLflow.dspy.autolog to make sure that we are able to collect traces, which will make it very easy to visualize and debug. And we'll start with Databricks GPT-5 Nano for our test by setting this model endpoint parameter. And we'll use a very simple complaint. My order took forever to arrive, and we'll pass along the sample order. So now let's run this. Now that we ran our sample test, we have a trace that shows that the DSPy model did as instructed, called a few different tools, got results from those tool calls, and then came to a final decision, which we can see here. The order overview shows items and total prices. The timing shows a delivery duration of about 25.5 minutes with delivered status. The actual delivery was faster than the P50 time, suggesting no delay or percentile benchmarks. And we ended up with a delivery delay complaint category, which makes sense. The decision to suggest credit with credit amount 0, which is what we told it to do when the claim of the complaint was not backed up by the data, and the rationale that we already covered. Now that we have verified that our agent is actually working, let's put together an evaluation data set that will let us try it out on a wider range of different types of issues. We're going to make an evaluation data set with 15 different complaint scenarios covering things like delivery delays, which we've already seen, missing items, food quality issues, service issues, even health and safety concerns, to make sure that the model responds how we want it to across all of the different areas, and to give us a baseline that we can use for model comparison and evaluation. So we're going to start by retrieving 15 different order IDs, and then we're going to match them to 15 different complaints. And this will give us a good mix of situations where the complaints and the order IDs actually match up. So, maybe there will be late orders that get matched up with complaints for late IDs. We'll have cases where people make claims about items that they never ordered. We'll have health and safety complaints that don't refer to specific contents at all. Having a diverse set of complaints is very important when you're coming up with an evaluation data set, because you want to make sure that you anticipate and plan for a wide range of different situations that can come up, so that you know how your agent will respond to all of them, and you won't be surprised when it sees something entirely new and responds in a way that you wouldn't want it to. So now we have defined our evaluation data set. Our next step is to define scorers. Now, what are scorers and what are they for? MLflow scorers look at the inputs, outputs, and traces from agent calls and provide assessments of the results, where the assessment gives some rating of how well the agent aligned with a certain set of criteria. Scorers come in many different forms. You can make entirely programmatic, deterministic scorers that might look at something like the word count of an output, or there are several different ways of making LLM and AI-based judges. We will be using two different kinds of AI judges, LLM judges, in this particular example. First of all, we're going to use the agent as judge approach for ranking evidence groundedness. Agent as judge scorers are able to inspect execution traces and use various tool calls themselves to parse and search the trace outputs. In this case, we're going to build a judge that looks at evidence groundedness, that makes sure that the decisions and rationales are actually based in the results of the real tool calls, that they're not making up any numbers, that everything is consistent with the data that is actually retrieved. Second of all, we'll be using a template-based judge to evaluate if a human could understand the decision logic based solely on the rationale. So this isn't measuring whether the rationale is correct or whether it uses data correctly. It's just asking if the final decision, which might be, for example, suggesting a $10 credit, is grounded in the rationale itself. This only uses inputs and outputs and doesn't use the rest of the trace. Now, one of the nice things that we can do with this kind of judge that we'll show with the rationale sufficiency judge is actually align the judge with human feedback. We can go through and provide human assessments on all of the traces, and then use the alignment API to align the judge with the human output. So very briefly, let's look at the scorers themselves. And I will run this cell so that the scorers are defined. The evidence groundedness judge, like I mentioned before, uses this trace template. So it will look at the actual outputs or the actual contents of the trace, making sure that the correct tools were called and making sure that the decision actually aligns with the data retrieved from the tools. And then the second scorer doesn't include the traces, but does look at the inputs and outputs. So its main role is to evaluate the decision that was actually made and figure out if that decision is well justified and understandable based on the rationale. So could a human that looks at the decision and the rationale understand why the decision was made based on the rationale? One other thing to point out before we move on is that you can choose which model you want to power your AI judges. So we'll use two different ones in this case. For our first judge, the one that looks at traces, we will use GPT-5 Mini. And for the second judge, rationale sufficiency, we will use Gemini 2.5 Pro. Okay, so we have defined our agent, we've set up an evaluation data set, and we've defined our two scorers. Where do we go from here? At this next phase, we're going to run a baseline evaluation. We're not going to compare models yet, but we're going to create a new instance of our agent with a single model. We are going to run it over the entire evaluation data set, which in this case is just 15 examples. This will generate traces of all of these examples, which we will judge with the judges that we defined above. We will also then provide our own human annotations on the rationale sufficiency assessment that we can then use to align that particular judge with our human feedback to make sure that it is judging exactly what we want it to and how we want it to. So let's do that. So we will use the Llama 3.3 70 billion parameter model for our baseline evaluation. So we can instantiate the new agent with that. And then we can get the new baseline evaluation run going. We call dspy.autolog again. We instantiate the agent. We create a new MLflow run to group the traces together. And you'll notice that we're doing this in two separate steps. We are first generating all of the traces and then running the evaluations. You don't have to do it this way. You're actually able to include a predict function right in the MLflow.evaluate call. But sometimes it can be easier to generate the traces separately and not worry about, for example, running into an error in the middle of the evaluation run and needing to start over. Once we run this, we will have a data set of traces that we can use and do what we need with going forward. So after we finish generating the traces, finish this initial run, we will retrieve the traces with MLflow.searchTraces. We tagged them to make them easy to identify, so they're easy to find. And then we will use the MLflow.GenAI.evaluate API, passing in the scores that we defined to actually create the assessments. Now that we've finished this baseline evaluation run, we have a set of traces that we can look at in MLflow. So let's navigate over to the Experiments tab and take a look at those. Now we've been logging to the DL Casper's model comparison experiment, so I will click into that experiment. And you can see that we have a collection of traces. And if we scroll over, we can actually see the results of our scorers, evidence groundedness and rationale sufficiency. Let's click into one of these and see what it looks like. In this one, the complaint was that the packaging was torn open when it arrived. So we can look at the details and timeline tab of the trace and see that the tool calls were made, and we can examine the final output. We ended up with a complaint category of missing items, which doesn't necessarily line up with torn packaging, and a decision to suggest $10 in credit. The rationale states that the customer's order, or it states the contents of the order, suggests a credit of $10 based on the condition of the order. However, from my reading of this, the decision to credit for $10 is not especially well justified. And apparently the AI judge, the rationale sufficiency judge, agreed with me. If we look at this, the judge correctly identified that the rationale does not adequately explain how the credit amount of $10 was determined, and goes on to explain in detail why a human reader would not be able to follow the chain of logic leading to the decision in that case. Like I said, we're going to align this judge with human feedback. So even though we agree with the assessment, we can add a new assessment by hitting this Add New Feedback button. It is assessment type feedback. We have a string data type, and we are also going to call this fail. And I'll just briefly note in the rationale that the credit amount is not justified. And we can create that feedback. Now, I won't show this because it will take a long time, but I'm going to go in and provide that feedback to all 15 of the rationale sufficiency examples, so we have enough data that we can use to align the judge. Okay, now we have reviewed all 15 of the traces and provided human assessments to all of them. For an example, in this case, the claim was that the Euro meat was undercooked and dry. The rationale offered a $10 credit, but the rationale sufficiency judge noted that there was a discrepancy and that the order did not actually include anything that would have Euro meat. And so it gave the fail feedback. And I also, in my human review, said that this rationale failed to meet the criteria and that this should have been escalated to review the discrepancy between the complaints and the order contents. So now that we have given this style of human review to all of the traces, we are able to align the rationale sufficiency judge with human feedback. So let's go back and do that. Align judge. So this is a pretty simple process. The API is very easy to use. We're first going to search for the relevant traces, which again, we've tagged to make them easy to retrieve. We define this under a new variable called traces for alignment, and then we simply use the align method on the rationale sufficiency judge on those traces. Now, this approach uses an alignment method, a prompt alignment method called Simba, which essentially uses the LLM to improve itself. It might come up with additional rules to add to the judge instructions, or it might come up with different examples after doing an analysis of different examples that it finds are challenging or currently misaligned. The end result will be a new judge prompt that is more specifically aligned with our expectations based on the feedback that we provided. And this step will take a little while, so we'll pause for a minute and come back once it's completed. Now that we have aligned our judge with human feedback, we're ready to carry out the actual comparison. We will be comparing two different models and seeing which one works best for our agent. The process is essentially the same as what we did before with the baseline, where we will first generate traces for each run of both different models. We will score those traces, including a score with our new aligned judge, and then we will review the results and see if we get any clear signal about which model works better for this use case and for this agent. So let's start this running. We will specifically be comparing Claude Sonnet 4.5 with GPT-5 Mini to see which one works better in the context of our agent. And as a quick reminder, while this runs over the course of this project, we first defined our DSPy-based agent. We put together an evaluation dataset of 15 diverse examples covering different types of use cases, such as delayed orders or missing items or just dissatisfaction with the food quality. We defined two different scorers, one of which evaluates the entire trace and ensures that the decision is well grounded in the data retrieved by the tool calls. The other of which looks particularly at the inputs and the outputs and attempts to guarantee that the measures whether the rationale is sufficient to explain the decision that was made. So now we'll let this finish running and we will take a look at the final results. Now that we have generated and scored our traces, it's time to compare the results. So once again, we're going to navigate back to the Experiments tab in MLflow. And to set up the comparison, what we'll do is select the runs with the evaluations in this sidebar, go to this actions dropdown and hit compare, which I've already done. And then over here, we are able to see the requests and how the different models performed. I added the model column over here so we can see which is which. The bottom one is GPT-5 Mini, the top one is Claude Sonnet. And we see, not incredibly surprisingly given the sizes of the models, that Claude Sonnet performed better overall in terms of passing the assessments. In fact, we see, but they were very similar. We actually only see one case where GPT-5 Mini failed. And if we look at the execution time, we'll note that GPT-5 Mini was consistently a bit faster across the board. So this brings us to an important point. It's not always about just getting the highest quality judge. Latency is also quite important. So it's a bit of a trade-off. We might find ourselves in a situation of needing to sacrifice just a little bit of quality on the margins to make sure that we have a model that is performant to the degree that we need for our application. So let's review what we covered. In this overview, we built a parameterized complaint triage agent using DSPy's React module with Unity Catalog tools. We generated a concise 15-question evaluation set and ran a baseline to create traces. We created 2 different judges, one of which we called evidence groundedness, which looks at the actual traces in an agentic way, and is able to identify tool calls and make sure that the outputs rather, are well grounded in the evidence retrieved. And the rationale sufficiency judge, which we aligned with human feedback via the Simba algorithm from DSPy. We also then compared multiple different serving endpoints, in this case Claude Sonnet and GPT-5 Mini, using the aligned judge, and we reviewed the accuracy and latency trade-offs. So in summary, Databricks lets you use whatever model you prefer. We have many different models available via model serving. Databricks also provides the tools that you need to evaluate and compare those models so that you can always use the best model for the job. DSPy's React module provides a very easy pattern to follow for tool orchestration and generally handling how we run and optimize our agent. Trace-aware judging lets us verify decisions against actual tool outputs and any other intermediate steps in the trace without needing to manually parse the trace. It has all of the tools it needs to search and parse the trace in an agentic fashion. And the template judge that we use to look at inputs and outputs can be aligned with human feedback to make sure that the judge is doing exactly what we want it to. So with all of this, we have the tools in Databricks that we need to choose the model that provides the best balance of quality, latency, and cost for our specific agent or AI application. Just a reminder, the blog post and notebook can be found in the video description. I recommend reading into those if you're interested in learning more about these topics. Thank you very much.